version of Chip Talks. This one I'm pretty excited about. I think this one will be one that we'll look back on, I would hope, from the future with some hopefully positive reviews. Today, Chip Talks is being sponsored by Neighborhood Nutrition. And also, I want to give a shout out and kind of dedicate really this Chip Talks to FECO Playbook. And let me tell you a little bit about FECO Playbook real quick before we dive into cancer. And we are going to talk cancer today. But FECO Playbook, if you're not familiar, FECOPlaybook.org. What does FECO mean? It's full extract can of oil. So it's just a moniker for fully extracted, the whole cannabis plant oil, right? So FECO Playbook they're dedicated to, the guy that founded it is a great guy, and he has sort of cancer in part of his family history, let's say, and has dedicated his life really to overcoming cancer and solving this cancer problem. And he's seen it work. And so FECO Playbook is dedicated to that. And then that effort has now launched here in Oklahoma. You might recall, if you're an Oklahoman or you live in Oklahoma, and I know people watch the show outside of Oklahoma, but here in Oklahoma, we had something called Operation Zero. And Operation Zero was a cannabis oil program for cancer patients where they could get their oil for $1. So FECO Playbook is joining forces with that old program, Operation Zero, and then they've kind of looped in Cindy and I into the effort, and we're happy to be involved because this is such a good effort. And it's going to be a little bit more than just the FECO strategy. So, and we'll talk that through, and that's why I want to really dedicate this show to that effort, because hopefully this will just be supportive of very synergistic, let's say, with kind of what that group believes. So anyway, with that in mind, we'll dive in. We'll dive in here in a second. Let me give my disclaimer first. I'm not suicidal. My wife is not suicidal. We love our life. We have a very good marriage. We just moved to a new location, our top secret location in Ada, Oklahoma, where I'm broadcasting from right now. But anyway, I just want to make that really clear, because sometimes people who delve into these subjects go away, and I have no intention of going away, and they know that. I'm a sovereign being. I claim my sovereignty with a capital S. I believe that God has given me this knowledge, so, there you go. I think I've got some friends. Okay, so we're going to dive in here. And I want to just start this discussion with, cancer is something that if you're a kind of a health researcher, let's say, everybody looks at cancer, right? So cancer is a big, big, big problem. Cancer's been around since, I think, 1200 BC was the first incidence of cancer. So this is something that's been with us a long time. I hope to point out some things, just let's say tie some threads together here in this podcast that have never really been tied together before. So we're going to come at this from a bunch of different angles, but we're going to start here with a slide. And again, if you're listening to this, I'll do my best to describe what folks, if you're watching it on YouTube, would be seeing visually. Because I know a lot of people do listen to this when they're driving and things like that. So I'll do my best, a good job, I almost said. We'll see if I do a good job or not. You will be the final judge of that. But anyway, we've got a lot of good information to go through today. This one might go a little bit longer. We're going to talk about cancer like you've never heard it talked about, but this is truth. And again, the only reason that I say that is I found these truths. So you can fact check me, please do. You can dive down any rabbit hole that I have, because I certainly, if I'm putting out a scientific statement, I'm not going to put that out and be, embarrassed by the outcome. I'm going to be able to defend my position with the staunchest PhD. And certainly, if you want to, feel free to dive in the comments. I'll try to be kind unless you get out of control, and then, I'll I'll do what I can do and try not to do. But anyway, we'll not go there. So it's a positive conversation. So we're going to talk about cancer. We're going to talk about, what might happen, what might cause it. We're going to talk about ways perhaps that you might utilize strategies to prevent it. We're not going to talk about, anything that's going to get or should get anybody in trouble, but we are certainly going to tell some truths here, okay? So here we go. And again, I've got some slides here, so we're going to walk through the slides. So bear with me with the slides. But I think it's important to get a visual here. And again, we're going to talk about a lot of information, and it kind of helps me stay on track, frankly, too. So what I've got up now is a slide about cancer. It's, the long and the short of it is it kills 7.4 million people a year. 1 in 3 of us will develop cancer. That stunned me. When I read that off this slide, I was like, wow. I saw this statistic in another place, but, I just want to point this out. So this is a $100 billion let's call it medical model, business model, all right? So is it in anyone's best interest in medicine to solve this problem? Maybe to sell a cancer drug, right? But again, they're making $100 billion off of 1 in 3 of us right now. I mean, who's going to go solve this problem? If you had a business that was making $100 billion on solving a problem, would you go try to solve that problem another way? Again, I'm just telling you the way that these people think, all right? And I certainly am not one of these people. I don't think that way. I'm going to tell you the truth, and I'm going to give you what I can to help you. So there you go. So what causes cancer? So again, I pulled this slide from a NIH study. Looks like 1995 there. By the way, in these I'll leave these slides down in the thread too after this goes live. And for the most part in the slides, I give everybody credit. So again, I'm going to, if I pull a study or something like that, I'll always give people credit. Okay, so I want you to notice a couple of things about this slide that I'm showing you. So I'm showing you, kind of normal cells down the one side, and the first mutation of those normal cells is good, but maybe there's an outside factor shown here as cell damage. And then there's a first mutation and cell damage, and second mutation and cell damage, and third mutation and cell damage. And then finally the fourth mutation results in a cancer cell. Well, that's kind of like, cells don't damage themselves now, do they? So what causes the cell damage? And again, that's causation. So what causes cancer? Well, something does. Something causes the cell damage. But anyway, this is a good description of kind of what happens. So these cells do get damaged somehow through each mutation. And as they continue to mutate, they will mutate into a cancer cell. Now, the important thing that I want to tell you, and we're going to talk a lot more about this here in a second, is that your body has a process for cleaning up a first mutation and a second mutation and a third mutation. So we should kind of never get there. And the fact that we get there is an educational issue, okay, that we're going to talk about. So this is important to understand, though, in cancer. If you could clean up the first mutation, well, you never get to the cancer. Okay? Important. All right, and then the other thing to import, there's no magical outside agent that acts here that causes cell damage. I mean, I can give you cancer with radiation, we kind of know that. But again, how many of you that have had cancer have, been around radiation? That's not what's causing it. So another way to look at this is cancer consistent and common? Like, do the more cells that you have equate to a higher probability of cancer? And that seems logical, wouldn't it? So a mouse would have less of a chance of getting cancer than an elephant. An elephant should have way more because they got more cells. And those cells can mutate because it's all about the mutating cells, right? So an elephant or a giant whale should get more cancer than we do or a mouse does, right? Well, no. It turns out that's not true. In fact, elephants and whales get far less cancer than we do. In fact, arguably, any animal in the wild gets far less cancer than we do. I wonder why that is. Diet. Shh, diet. Shh, 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 don't tell anyone. But for cancer and for whales and elephants, it's a little bit different, and there's a specific reason. But again, if you think about a deer in the wild, 33% of us will get cancer, 1 in 3, right? 33% of us will get cancer. If you're a hunter and you hunt deer, how many cancerous deer have you ever shot? Yeah, that. I mean, wild animals just don't get cancer, okay? Bring them into captivity and you feed them the same crap we eat, they get cancer. And we'll talk about why that is. But anyway, this is something called Peto's paradox that about cancer, right? And so, we should have this incidence of, smaller animals get less cancer, and as you get bigger, we should have higher incidence of cancer. And it just doesn't work. So it doesn't work. And what this suggests, and the only reason that I'm pointing this out, is that cancer is not, not caused by mutating cells. Because if it was caused by mutating cells, a whale would have a lot more cancer than we would. Okay? So, and there's more to this story, but that's the paradox, all right? So, interestingly, there are these things called tumor suppressor genes. And again, if you have cancer or love someone who has cancer, you probably heard about, P53, P53 pathway. If you're a physician, if you're a researcher, I would hope you've heard of the P53 pathway. But P53 is a gene, that expresses a protein that helps us fight cancer. Okay? It helps us fight cancer. Did I already say that? No, we'll come back there. Yeah, so anyway, P53 helps us fight cancer. And we have one copy of the gene that builds the P53 protein. Okay? So humans have one. These guys, sorry, I thought I had this on a slide, but whales and elephants have like 50-something copies of P53, okay? So, it's right there. African elephants have 20 copies of a tumor suppressor gene called TP53. All right, and we only have one copy of this gene, all right? So why do elephants and whales get less cancer than we do? Well, part of the reason is because they have more P53. So P53 is looking like a way that we fight cancer, all right? So, and it absolutely is a way that we fight cancer. And this is well known and well established. Again, feel free to, dive down the rabbit hole of research. Now, the other interesting thing I want to point out is, interestingly, autistic people who have genetic mutations everywhere, you would think would be at more risk of cancer, right? Because things mutate. And again, isn't cancer mutating cells, as we're told? Well, autism patients, again, there's this article, autism patients have more cancer gene mutations, but lower cancer risk. Huh. Isn't that interesting? Boy, if you're a scientist, your ears should be perking up now like crazy. It's like, oh, what? That's interesting. Now, if we look at P53, what happens? There's some studies out there. So you guys might want to go read these studies about autism and P53 and cancer and how all that works together, because again, there's good clues as to treatment. There's one right there about salvia. Salvia is called sage. Yes. All right. Anyway, P53 and cancer research. So, and I also want to point out, I'm not trying to hide anything from anybody. Look it up here. 15,000 results. Okay. Yeah. So, does somebody know about this? Somebody knows about this. All right. So, P53 and cancer research. This is about mice, but mice are very characteristic of humans. So again, we're looking at P53, and could P53 be related to cancer? Well, we know it is, but P53 is kind of what'll suppress cancer. So and it will kill cancer. P53 is our way to kill cancer. It's our kind of emergent. It's like a fire extinguisher, right? So cancer is a fire. And a fire turns on, we hit it with some P53 fire extinguisher, and it puts that stuff out, all right? So it's useful, though, to study, like if you had an animal that couldn't make any P53, they do this to mice. It's horrible. They genetically alter them where they can't make proteins. And again, it helps with research. It's kind of horrible for a mouse, though. But they managed to knock out, and they call these knockout mice or null. And so they managed to knock out the P53 gene. All right. So these null mice have an average time to tumor development of 4.5 months. Now, they always develop tumors. Okay. So 4.5 months. So if you have a mouse and you don't give him a fire extinguisher, he's going to develop a fire in 4.5 months. Now, what about you? Okay? So, again, P53 is the important thing here. This last bit is and sometimes they'll have a mouse that will express the gene and kind of not express the protein. Those guys took a little longer, 18 months, but again, they all develop tumors, sadly. If you just Google, P53 and cancer, again, I know this is not a real good representation of search, but, 72 million results. And when the first result that pops up is, results from Nature or other major publications that, publish scientific articles, that usually means that those two things are related. So P53 and cancer, Google says they're related. So there you go. Now, wouldn't it be important to look at, well, if this P53 is important, and it sure looks like whoever they is know about it, because there's a lot of search results about it, and there's a lot of study about it, well, could there be something that is inhibiting it inside of us? Could something block P53 and thereby make us, what was it, a mouse? How many more times? 4.5 months to develop cancer? If you're a mouse, that's a bad thing. I mean, you need P53. So could something be inhibiting P53 inside of us? Yeah, bacteria. Microbial regulation of P53 tumor suppressor. One particular mechanism that may be targeted by bacteria is the P53 DNA damage response, also your cancer preventative. Inhibition of P53 may allow bacteria to subvert the host cell cycle control and apoptosis mechanisms, meaning you can't kill cancer, resulting in inhibition of cell death. A mutated cell stays alive, and survivor of host cells damaged by infection. Mutated cells again. We'll talk about how to get rid of them in a second. But back to that slide, a lot of mutation without P53. In this other study, and again, this is microbial regulation, again, of P53 tumor suppressor. Bacteria inhibit P53 through multiple mechanisms. Bacteria inhibit your cancer preventative through multiple mechanisms, including protein degradation, transcriptional inhibition, and post-translational modifications. Current research revealed that P53 has a role in controlling the bacterial infections, and that inhibition, I guess, of P53 may confer certain selective advantages to bacteria. They like to inhibit it. Bacteria. Okay, so again, how long have we known about this? This will piss you off. Certainly if you've ever had anybody die that you love of cancer. We've known about this since the 30s, guys. So you can look up a guy named Royal Rife, okay? And Rife was a layman. He was a guy like me. So he didn't have PhDs after his name. He wasn't an MD. He wasn't a scientist. But he was a smart guy. I'm not saying I'm a smart guy, but Royal was a smart guy. And he actually took a bunch of odd jobs, and he ended up being a chauffeur to this really rich guy. And so he sold him on some of his ideas, as all of us poor laymen must do, sell some rich fella or, some scientific fella. But anyway, he sold somebody on his ideas, and so Rife was a very dedicated scientist. So even though he had no letters after his name, Rife was a very dedicated scientist. And what he did with the investment that he raised was he went and first of all, he built a microscope. Now, he was all about cancer. This was in the 30s, okay? He built a more powerful microscope than it had ever been built before. As a layman, he wasn't a PhD. He's just a guy like you and me, okay? Just a guy. He just had resources. But anyway, he built this really cool microscope. And with this microscope, he was able to see cancer, what he thought was cancer. But one of the things that he felt like he had to do was make cancer. Make cancer, okay? So in order to prove this, he felt like he had to be able to make cancer and then see it in his microscope, and then he later learned how to kill it, okay? So let me read you this, because I think it's important to read I want you to understand the rigor he went through, the accident that he used to discover this, and we'll talk about this in a second, the rigor that he went through to duplicate it, and basically everything that he did to prove out his theories. And again, he was so easy to marginalize in the 30s because that was when the Flexner model was happening. That was when everybody was getting criticized for everything. If you didn't believe in pharma, if you didn't believe the pharma model, you were cast out. Goodbye. See you later. And it was easy to do it with Royal because he wasn't a PhD. After many long procedures and unsuccessful attempts, Rife had fortuitously placed a test tube near an argon discharge tube. Now, it doesn't really matter that it was argon. This is what matters. It ionizes air and produces O- ions, becoming ozone. Rife noted some cloudiness, but the microscope revealed nothing special. After incubation during 24 hours at 37.5 degrees Celsius, on K medium was a sugar medium, glucose medium, you can think of it as agar medium, the solution was teeming with cancer viruses. So he accidentally left a test tube that he was trying to grow cancer in by an ionizer, and because of the O- ions, which again is interesting, isn't it? That created a situation where that bacteria could grow and, again, create cancer, and it is a bacteria. These entities were very small and motile, but easily discernible by means of their purplish fluorescence. Yes, cancer fluoresces. It's a luminary. If you're a philosopher, I hope you're just doing like your jaws on the floor. Purplish fluorescence, by the way. If you know much about elitists and the people who want to claim that they rule over us and rule the world, they all wear purple. Anyway, purplish fluorescence. Their proliferation resulted from subjecting bacteria to stress. Since Rife had been searching these mysterious entities during many years, he called them X bacteria, or simply BX. To verify if they did really cause cancer, he inoculated albino rats with a solution derived from human breast cancer tissue. In almost 3 to 4 days, there appeared a lesion at the point of inoculation in the mammary gland of these rats. He gave them breast cancer very easily. Pathological examination disclosed typical malignancy. Rife mentioned that same procedure was repeated 411 times with identical results. That was the big bit I wanted to get to. He wanted to be absolutely sure. Well, no joke. And when you're a guy like Rife, without credentials, you have to be absolutely sure before you go out there, like going on a Chip Talks and talking about cancer. The culprit of cancer, at least a new possible cause, had thus been uncovered. It was a tiny ovoid particle, about 50 nanometers large and 70 nanometers long. Its motility indicated that it was flagellated. It could swim. Rife observed also with his super microscope that these BX entities could be transformed again into bacteria or fungi according to the medium where they were living. So it mattered where they were living. In their reduced form, they could not be destroyed by UV radiation or X-rays. Okay, and this is important because, again, part of my strategy previously for killing things has been UV. So it's interesting that, and X-rays are even stronger UV rays, but they were killed after 2 days at 42 degrees Celsius, which is a little too hot for most of us to survive, but it is a way to kill these little guys, right? So the newspaper article attracted the attention of Dr. Arthur Kendall, who had developed the K medium. And again, the K medium is just where they were growing these things in, like agar you can think of, if or glucose or sugar. Sugar might be better. Dietary sugar would be perfect. He was a professor and head of the Department of Bacteriology at Northwestern University in Chicago and wanted to check the reality of these amazing claims. So again, you can read about Rife if you want to know more about Rife. Ping me. I've got there's a really good paper written by Rife where this PhD, very weighty PhD named Messine, proves all of Rife's science. So again, it's not like just sat there. So it's been proved and reproved, but somehow never adopted into the pharma model. Now again, $100 billion a year cancer's worth. Is it in their best interest to solve it? You can figure that one out. Okay, so this is Rife's tables. Again, if you go look at Rife frequencies, you're going to see a chaotic mess of crap. All right? This is Rife's frequencies. So if you want to know what Rife's frequencies are, here they are. You don't have to look any further. And this is all that he had. Now, since then, they have found that, again, there's a lot of things that these frequencies work for. But I would argue very heavily, Rife was able to see these bacteria, classify these bacteria, and this was all the bacteria that he saw with his super duper microscope that I guess we're not allowed to build anymore or see anymore. But this is it. If you want to know the cause of disease, you're looking at it right there. Now, the other thing that I want you to look at on here, or I'll describe, but is the figure on the left. So the first figure on the left is a gas, you can think of it as like a light bulb, a gas plasma tube with just one of the refractors on it bent a little bit, okay? So in the bending of that refractor emits a frequency, okay? And so this is what Rife used to emit these frequencies. This matters because there's more to the story here, and without going into quantum mechanics and quantum physics, let's just say that there's more to the story here, and that emitting through a gas plasma discharge is good. All right, so there's something to that. all you physicists and, electrical engineers and cancer solvers, there you go. So go solve the problem. It ain't hard to solve, but you've got to know the whole picture, and you're not taught right now, sadly. Okay, so P53. Well, now we're going to introduce, so how do I influence P53? With nothing, with certainly I can, if I give you the right kind of bacteria, I can shut it down. I can shut it down in a lot of different ways. And so P53, if you don't have enough D, I haven't even looked at this, but well, I don't want to do the Google search while I'm live, but I'd encourage you to look at vitamin D and P53, because I can almost assure you that a lack of vitamin D will cause a lack of P53, okay? But anyway, we won't dive down that one yet. We'll just go down what we've prepared for today. And that's AMPK. So you hear me talk a lot about fasting, the importance of fasting. And again, we're going to talk about that more in a second. But why does fasting work? It pushes a button called AMPK at the cellular level, the kind of highest or lowest level, however you want to look at it. But AMPK gets pushed. Guess what happens when you push the AMPK button? It pushes the P53 button. You initiate P53. You build P53. You kill your cancer when you push the AMPK button, okay? That's, again, does AMPK work with bacteria? Yes, it's how your body fights bacteria. We're going to talk a lot more about this. All these things tie together. That's why it's so exciting. We've found highest truth, perhaps. There's always higher truth, always. But anyway, we found a high truth, let's say that. AMPK and P53. So the P53 family of proteins has an important role in determining cell fate in response to different types of stress, such as DNA damage, hypoxia, or oncogenic stress. You need it to fight cancer, is what that says. In recent years, P53 has also been shown to respond to metabolic stress. Again, I can give you cancer with putting you in the right metabolic state, is kind of what that says. And it's kind of what's being done to you every day, all right? But again, you can get out of it. It's really easy. And anyway, respond to metabolic stress and to be induced by the AMP-activated protein kinase, AMPK, a central cellular energy sensor. AMPK activates P53. Okay, great, Chip. That's wonderful. You've, figured that stuff out. So how does that help me? I've got cancer, or my kid has cancer, or my dad has cancer. I'm dying of cancer. How does all that, logic help me? Well, again, now we have ways to look at, can we influence AMPK inside of you? Yes. Yes. Very easily. And again, we can do that through behavior and diet, which we're going to talk about. We can do that through cannabis, and this is why FECO Playbook is so important. And if you live in Oklahoma, why a cannabis, strategy would be so important, and why if you have cancer or love someone with cancer, you need to get them their card and get them signed up now. If you need to get them their card today, we've got a way to do that, or close to today, very quickly. So there's a cannabis strategy, and then there's also an anti-parasitic strategy that I want to talk about. So if you've heard about like ivermectin, fenbendazole, all those guys, this is how and why they work. And again, all of these you can use together, and you never have to rely on the medical system. Yes, truth. All right. Okay, so diet and behavior. What do we do? Well, again, so how do I push the AMPK button? I don't eat for 5 hours. That's it. Don't eat for 5 hours. You go AMPK forward and you start making P53 to kill cancer. You also, when you do that, not eat for 5 hours, you put your immune system in cleanup phase. So you'll recall I said we're going to go back to this slide. Now we're going back through all the slides. I hate to do it so fast. Ooh, boink, boink. This one. So what I'm showing you is first mutation, second mutation, third mutation. 5 hours after you eat, your body goes into a state, they call it fasting, but that's a bad state because, again, all you need to do is just not eat for 5 hours. Is that fasting? I don't think so. It's normal. So let's call that normal. What science would call fasting, let's call normal. But anyway, when your body goes into a normal state, you clean all this up. It doesn't matter. You don't have second mutation, third mutation, fourth mutation cancer because your body does something called autophagy. I never can say it right. I always feel like I'm mispronouncing that word, but you don't go into that mode until you're in normal or fasting mode, okay? So 5 hours, don't eat for 5 hours. Now, depending on the severity of your cancer, I would say there's two strategies here. One strategy is to fast. And again, you can go 40 days. Don't do this right off. You need to prepare yourself a little bit. But you can go 40 days without eating, okay? So the human body is designed, you can go 40 days without eating. Now, if you have cancer, you're already probably depleted of some things. So we need to have some discussions. You need to do maybe a day or two of prep work. But you don't need to fast for 40 days. But depending on the severity of your cancer, I would sort of use one of these two strategies. But we'll start with a less aggressive strategy. So the easiest thing to do is intermittent fast. There's tons of information about intermittent fasting on the web. And here's why you need to intermittent fast. Most of us are taught we need to eat breakfast, lunch, dinner, and most of us will eat something, right before, like a cookie or something right before we go to bed. Dietary sugar we'll talk about in a second. That is bad for cancer. It's like building a perfect petri dish for cancer that's good for cancer, I guess, if you want to grow it. But it's, bad for us if we want to prevent cancer. But anyway, on behavior. So, and again, your body will go into a different state when you eat. So, intermittent fasting is sort of the least aggressive way to start with this. Most of us can eat within, let's say, a 10-hour window or an 8-hour window. Now, the smaller you make that window, the better. And the reason for that is you want to, after you finish eating, so after your eating window, let's say, you've got a 5-hour timer, right, until you go into normal mode. And then when you go, you want to be in normal mode as long as possible. So something like a bear, and this freaks everybody out. I always ask people, I ask the people that I help, that I consult with, that counsel with. I'll say, a bear comes out of the cave in the winter, or spring, right? That's a hungry bear. How many hours a day do you think that bear eats in the spring and in the summer? And they'll say usually around 16 is, the answer I get. And that's not correct. 2 hours. That bear will eat 2 hours. Right after it might eat a lot. And again, it's not about volume. It's about frequency in metabolism. So it's about frequency, okay? And it's about frequency here in metabolism because you want to put your immune system in the Pac-Man mode, the autophagy mode, where it's gobbling up all those half-mutated cells so they don't become cancer. So we want to stay in this mode as long as possible. So a bear knows this. Again, a bear is, weak when it comes out. It needs a strong immune system. It needs a strong stress response. It needs to promote leanness all through the spring and winter. When a bear needs to get big to promote putting on weight so it can hibernate, it then changes its eating behavior. It starts eating 20 hours a day. And it gets big, really big. So there are no fat bears at the end of summer because they've been eating only 2 hours a day. All bears are fat at the end of fall because they all start eating 20 hours a day. Hopefully you're getting the picture. So the smaller you can narrow that window, and again, if you can get it to, Cindy and I do, a 4 or 5 hour window. which has become super comfortable, right? So we'll eat our big meal at, 4 or 5 o'clock, and then we'll kind of graze and snack until we go to bed. And again, that to me appears to be kind of the right way to do it. We eat, one kind of big meal in the evening, and that kind of gives our body the energy and stuff that it needs to be able to break it down, and then we use it during the day. So anyway, intermittent fast is least aggressive. So if, again, you have a cancer that's not life-threatening or super aggressive, and even if you have a cancer that's life-threatening or super aggressive, intermittent fast now. But you might want to consider, longer fasting depending on how aggressive your cancer is. So if you've been given the death sentence, again, fast. Because this is your body, when you're in this state, I cannot stress this enough, cancer not only cannot eat, so it can't grow and it can't stay alive, point one. Point two, it's got nothing to eat. Because 48 hours, and again, if you're intermittent fasting, this doesn't quite work this way, but you are cutting down the glucose. So cancer lives on glucose. Cancer lives on sugar, sugary hormones, or sugar-like things. So if you can get rid of all your sugar, it's got nothing to eat. 48 hours after you take your last bite, as long as you don't eat anything else, your body will have 24 to 48 hours, your body will have burned through all the glucose, all of your circulating glucose, food for cancer. Okay? At that point, cancer won't have anything to eat. It can't eat ketones, and that's what your body uses. It's sort of you use a water-soluble fat that your brain and liver use for fuel when you don't have glucose, okay? And cancer can't eat that, all right? So when you're in normal mode and you stay in normal mode long enough, cancer can't eat. It can't survive. It cannot live. You can put your body in a state where cancer cannot live, is what I'm telling you. It doesn't matter how bad your cancer is. You can do this. Okay, and then the last thing I really want to talk about, and you guys can read through these, but again, even if you're going through chemo, the intermittent fasting is going to help. You want to kind of work with the problem, not against the problem. If you're eating a lot of sugar, I hate to point you out, I'm not going to name you, but I'll give you an example of something because I just talked to this person this morning. So, and again, this is well-meaning, well-intentioned. You'd think that this would be the right thing to do. And this person was taking FECO, but taking it in the form of a sugary candy and doing it frequently. So again, if you eat 50 calories in the morning, you go into gear one, you go into sort of let's call it low functioning mode, right? And then every time you eat more than 50 calories, you just sort of reset that 5-hour clock to stay in low functioning mode. So sugar will do it quicker than anything else. And sadly, I know some of us like to drink. I quit drinking a while back, but alcohol will definitely throw you right into sleepy time mode, right? So our bodies we call this over here, we call fed in metabolism. So if you start reading about this stuff, I would call this our idiot mode, or kind of just a sleep mode. We don't want to be here very long, right? Fasting, again, in metabolism, that's what they call it, fasting, that's where we want to be. That's our normal mode. We want to be there as long as possible. And then we've got a third gear that, it's a little too woohoo for right now, but cancer certainly doesn't live in third gear. And third gear is achievable. It's looking to be. We need to kind of do some things in order to prepare ourselves, but we can function in a different way than we think. Let's just put it that way. All right. Oh, back to this real quick, because again, why does this work? Well, what is the cellular switch between fasting and fed, or idiot mode and normal mode? AMPK. All right? AMPK is literally the high-level cellular switch that flips you between fasting and fed. You're not in fasting until you flip AMPK forward, until you start producing AMPK, okay? It's the thing. It is the switch. It is the thing that says, I'm in fasting, or I'm in idiot, slow, dumb mode, or I'm in normal mode. And I don't mean any most of us live over here, and, we do. But I want to really illustrate the point of, cancer lives over here, not here, okay? Hopefully I don't need to just say anything else. Hopefully it's all hitting home. I always ask for feedback when I'm talking, to audiences. Hey, are you guys getting it? You understanding? When I'm teaching a class, and so it's a little hard to do with a live because I can't really ask you for feedback. Hey, are you guys getting it? You understanding it? But hopefully you are. Okay, so strategy number 2 on how to kill cancer with no pharma and no doctor. Cannabis strategy. All right. So this one's flying without a net for a lot of us because are we going to trust the bud tender and, folks like Chip, or are we going to, trust medical science, right? So, but the cannabis strategy, why does it work? First of all, well, looky, if I affect your CB1 neuroreceptor, it pushes the AMPK button. What a shocker and coincidence. So activating CB1 will activate AMPK. That's all there is to it. Enough said, really. So what activates CB1? THC activates CB1 strongly in cannabis, right? So THC is a necessary thing if you are using cannabis to fight cancer, and it is going to be the thing. Now, if you do this in conjunction with a behavior and diet strategy, well, now you're sailing AMPK forward, right? You're going with the flow. And this helps. Again, you're going to it's synergistic. Anything you can do to push that AMPK button if you've got cancer, you want to be pushing that button because it makes P53 that kills your cancer, right? You guys getting this? Isn't it cool? Yeah, so activating CB1 will absolutely push the AMPK button, which pushes the P53 button, which will kill your cancer. Cool. All right, so is there more to this story? Yeah, kind of with cannabis. I mean, there's some things that help. AMPK is a wily button to push, all right? So it takes some big motion to push it. So what helps with cannabis? Well, again, it looks like it is helped by a channel called TRPV, all right? So, and it's looking like for real AMPK activation, you've got to activate TRPV. All you FECO guys are going to love this. I'm just saying it because this is the why. This is the why distillate doesn't work the same as FECO. Because you got to have a whole plant. Because TRPV has to be activated. And TRPV is activated by some terpenes. TRPV is strongly activated by CBD. Okay? And if you have distillate, like a THC distillate, you don't have any terpenes or CBD. If you have full extracted canna oil, you do. Okay? So this is why it's a better strategy to use FECO than it is. Distillate will work. Okay? So distillate will push, the CB1 button, which pushes the AMPK, which pushes P53. And that's why people do get success with distillate, but it doesn't work as well as if you use it whole plant. So you've got to have some CBD in there ideally, or some terpenes that push the button, either one. There's a little bit more to this, but we'll kind of leave it there. But that's the why. So hopefully all you FECO folks who've argued with the distillate folks are now satisfied and happy. There's your ammo. And again, I'll leave the PDFs, but I always reference the studies and stuff and everything I do. So there's a reference down there that you can go pull the study yourself and read it for yourself. So the last area that I want to talk about is antiparasitics. A quick story on this: that Cindy and I were helped, let's say, with a marijuana law here in Oklahoma. And right after we passed the law here, I got a call from one of the news stations. And I was, if you guys are in Oklahoma, you see me on the news a lot, right? So certainly if you live in Tulsa, you see me on the news a lot. But anyway, I got a call from one of the news stations in Tulsa. I said, Chip, we've got a guy who's recovered from cancer. And he says all he was using was a dog dewormer, CBD, and vitamin E. And this is, if you guys know about this story, I mean, it's now turned into a big story. They go, what was it? How did he do it? Is this right? Could this have happened? I go, Well, I know, vitamin E really doesn't kill cancer, and CBD, has some interesting properties as we just talked about here at cancer, but it doesn't really kill cancer. Might have been the fenbendazole. But anyway, so that story's out there in the Tulsa world. You can look it up. But that caused me to look into fenbendazole. Fenbendazole, wow, is it good for cancer? Fenbendazole is related to, so fenbendazole is it's an animal product. So it's an animal, basically anti-parasitic. The human version is called menbendazole. So if you want to go poking around, you can look at fenbendazole and menbendazole. And we'll talk about why these guys work in a second. But the ivermectin would be in the same class. So again, if you've ever heard, well, ivermectin, if you have cancer, you need to be taking ivermectin. Ivermectin is an anti-parasitic. Yeah, think about that with COVID now. Let's go. Shall we go back to the Rife slide with the bacteria that cause everything again? Because COVID's just a manifestation of those. Yeah. So ivermectin, anyway, works with a lot of things, right? By the way, do you know this? Just on COVID, real quick. I think we're going at cancer. We might as well go at COVID. So the PCR test. So the tests, that we've all had to take for the last freaking however many years, those are bacterial tests. Yeah, they test for bacteria, not a virus, because viruses are caused by bacteria. They just don't tell you that. But again, they've had to disclose all this information through all this stuff, and again, we're getting closer to the truth, aren't we? So we'll get there. We'll get there. The truth tellers are out there. We'll break down the walls. But, again, I will, no matter what. I might not have the following that some of those other people do, but we'll tell some truth here. So anyway, the anti-parasitics, why do they work? Well, they work through mitochondrial action, at cancer, which is good. Again, you want all these mechanisms of action. So you kind of say path 1, path 2 is cell arrest cycle. Path 3 has to do with calcium, and they kind of disrupt calcium. Endocannabinoid, by the way. Path 4 has to do with autophagic death. So that is the AMPK button. So I just want to point that out, that again, we're talking about the same mechanisms of action. These anti-parasitics are a little bit more broad. So again, if you're trying to kill cancer and it's a parasite, well, you'd think that you'd want an anti-parasitic. The way that these guys work is they really their main mechanism of action, other than kind of, it looks confusing what we're looking at the slide, is they disrupt cancer's ability to eat. So cancer builds tubes out, and then it kind of sucks in glucose, mainly sugary stuff, through those tubes, and that's how it eats. Well, these anti-parasitics disrupt cancer's ability to form tubes. They're called anti-tubules too. Important to form tubes, very important for us. So, but anyway, those are 3 different, so hopefully in summary, what we've done here is we've done the what, we've done the how, we've done the who, and we've done some things that you can do. So, what is cancer? Well, Rife found and proved that cancer was a bacteria. If you want to satisfy yourself to his proof, go read about him. Again, you have to discern through a lot of what you're reading, because he's been, he didn't win the argument. To the victor go the spoils and the history, right? So victors get to write history. But you can find enough out there about Rife to, find the truth for yourself, let's say. Okay, so and how is cancer caused? How is cancer caused? I've been talking for a while. Yes, 54 minutes. I need to shut this down. How is cancer caused? A weakened immune system allows the bacteria to develop. So again, bacteria in the proper medium with a weakened immune system. When you're in gear 1, when you're in fed, you're weak. It's easy to take root. Who is at risk for cancer? Anyone in gear 1 over here. But anyone with a weakened immune system, and you will be at risk for continuing to have cancer if you continue to kind of do the same diet and behavior. Honestly, there's no magic manna over here that will, get you here. It's up to you. You can do it yourself. So things that you and I can do to prevent cancer, or if you love someone, again, things that have been shown to help with prevention treatment, okay? So depending on the severity of the cancer, consider intermittent fasting for less aggressive cancers and consider immediate fasting for more aggressive cancers. And again, if you have a child that has brain glioma, and, loves her cookies, right? That's a tough thing to do, but I'm just telling you it'll work. So, it has been shown to work. I'm not going to gaslight you. It has been shown to work, all right? So, the other thing that you can do, consider immediately starting anti-parasitics. Oh, I left a open bracket in there, so anti-parasitics should be there. These are proven to have high safety and also to work. And you can say there's a great paper repurposing, I think, anti-parasitics for oncology. There's some really, really good summary papers out there, so they're pretty easy to read on these anti-parasitics and cancer if you want to kind of prove it to yourself. And then also, I would consider getting a medical marijuana card if you have cancer and following the FECO Playbook strategies. So these are super duper important. FECO Playbook, again, is going to incorporate the strategies that I've talked about in this talk. We're already, doing that. So they're already doing that with the dieting. They're already doing that with some additional things. There are herbs that you can take, again, that push these buttons that we'll be talking more about. So kind of anti-cancer herbs, if you want to call them that. But they're all focused on pushing this AMPK button. Again, if you're an aspiring researcher or scientist or physician or whatever, feel free to contact me if you want. Again, I talk to people every day about what we talk about here on this show. Other than that, we'll see you guys next Friday. Not sure what our topic is going to be. Oh, I think we are having our we're opening neighborhood nutrition. So if you're in the Ada area, certainly feel free to come by and have a chat. And I believe that Chip Talks will be focused around answering some Q&A around that opening. But we will see. Stay tuned.